Recording.
Alright, the problem we're going to do today is number 686. It's a machines problem. The problem statement is the platform scale consists of a combination of third and first class levers so that the load on one lever becomes the effort that moves the next lever. Through this arrangement, a small weight can balance a massive object. If X equals 450 millimeters and the mass of the counterweight S is 2 kilograms, determine the mass L required to maintain the balance. So our approach on this problem is going to be make section cuts, then draw free body diagrams of each different section, and write out the equilibrium equations for each of those sections and solve for our unknown forces. So on this page, we make a cut at the joints that connect to the piece holding the counterweight, S, which is 2 kilograms. Our reaction forces are at the joint, and since the member ED back here is vertical, we can assume it's a two-force member, so we can just model that as a single force pointing up. And so we can do a moment around C with counterclockwise as a positive orientation to solve for the force of member ED. You get FED times 100 millimeters minus 2 kilograms times 9.81 meters per second squared times 950 millimeters. And when you solve that out, you get the force FED, or the force in the member ED equals 186.4 newtons. We can then move on to the next section, and now we see that we have FED, so we can do a moment at this joint here to solve for the force in the member BG, and so that moment equation goes like FED, which we know, times 250 millimeters minus FBG times 150 millimeters. We know that is 186.4 newtons. And when you solve that out, you get FBG equals 310.7 newtons. We now go to our final cut, which is this section right here with the load L on it. And we now know FBG. So to cancel out the reaction forces, it's convenient to do a moment around A, which equals 0, and that equation works out to be FBG, which we know, times 500 millimeters minus the mass of L times 9.81 meters per second squared times 150 millimeters. And that 310.7 newtons. And when you work that out, the mass of L equals 106 kilograms. And so now we have solved for the load L that will balance out this system when the counterweight S equals 2 kilograms.